So one of the great things we can do with gas laws is solve for the gram formula weight. This is very often called molar mass or molecular mass, and in fact that's what I've called it for all of my years of teaching, but I decided to switch it up for you guys and call it gram formula weight because that's consistent with what we've learned. So if you hear me say molar mass or molecular mass, because it's things that I've said in the past, know that it's the exact same thing as gram formula weight. So we're going to use the abbreviation of GFW to be gram formula weight. We use N for the number of moles, and we're going to use M for grams of something. So gram formula weight is equal to grams per mole. We know that that is part of our definition. It's how many grams you have in a mole. So 1 mole of water has 18 grams, and we refer to the gram formula weight as 18. So if we solve for moles, which is N, which is our variable N, if we solve for moles by rearranging this equation, it's grams divided by gram formula weight. If I substitute grams over gram formula weight for N in the ideal gas law, so where I had N, so PV equals nRT, instead of N, I put in grams over gram formula weight, and then I'm going to rearrange it and solve for gram formula weight. So gram formula weight is equal to grams RT over PV. And that's going to be our equation, our simplest way to solve for gram formula weight as sort of a one-step problem. All the rules for using PV equals nRT still apply. Kelvin, liters, gas law constant. So the problem says, what is the molecular mass? And I left that in there because you're going to see it asked a lot in your textbook and stuff as molecular mass. So I wanted you to see it in a problem. So the gram formula weight, I put that there, of a gas, if 8.11 grams of it occupies a volume of 2.38 decimeters cubed at 109.1 kilopascals and 10 degrees Celsius. So our equation is gram formula weight is equal to grams RT over PV. Now we have some adjustments to make. Grams is okay. That's going to be my grams that I'm going to put in. Decimeters cubed, okay, we should know at this point that that's a liter. So we really have 2.38 liters. 109.1 kilopascals is okay. 10 degrees Celsius plus 273 equals 283 Kelvin. So my gram formula weight is equal to grams, 8.11 grams. My R, because I have kilopascals, is going to be 8.31 liters kPa, moles Kelvin. And my temperature is going to be 283 Kelvin. My pressure is 109.1 kPa. And my volume is 2.38 liters. So go ahead and type that into your calculator and see if you can calculate the gram formula weight. Did you get 73.5 grams per mole? If you did, then you are correct. You could go on and use that to find a molecular formula if you had an empirical formula. I mean, there's so many ways to tie all of this together. Let's take a look at one more. A gas is collected over water at 21 degrees Celsius and a pressure of 750 millimeters of mercury. The gas had a mass of 0.128 grams, a volume of 100 centimeters cubed. What is the molar mass of the gas? The water vapor pressure at 21 degrees Celsius is 18.7 millimeters of mercury. So we have a gas collected over water. So this is our picture that we drew yesterday. So in here I have the gas, whatever it is, plus the water vapor. I know that my total pressure is equal to 750 millimeters of mercury. And I know that that's equal to the pressure of the gas plus the pressure of the H2O. The water vapor pressure right here is this 18.7 millimeters of mercury. So my 750 millimeters of mercury is equal to the pressure of the gas plus 18.7 millimeters of mercury. Since millimeter of mercury and torr are the same thing, I'm just going to change my units to torr so that is more consistent with what we've been doing with a constant. So I'm going to subtract that, and I'm going to end up with the pressure of my gas equal to 731.3 torr, which is exactly the same as a millimeter of mercury. The gas had a mass of 0.128 grams and a volume of 100 centimeters cubed. This is equal to 100 milliliters. Milliliters aren't going to do us any good, so we need to divide by 1,000, and we have 0.1 liter. Okay? So we're going to use our formula. Gram formula weight is equal to grams RT over PP. Gram formula weight is equal to how many grams? So I had 0.128 grams. In this case, I'm using torr, so it's 62.4 liters torr over mole Kelvin. My temperature is 21. So 21 is not useful. I need to make that into Kelvin. So 21 plus 273 gives me 294. My pressure is the pressure of the gas, so 731.3 torr. And my volume, in this case, is my 0.1 liters. So my gram formula weight in this case, so go ahead and pause your computer and try to solve it. So my answer in this case is 32.1 grams per mole. Any idea what gas this is? If I gave you a list of choices, it might be obvious, but what gas weighs 32? Okay, so you can look at the periodic table. If you look at our ones that are gases, obviously it could be a compound and that would make it harder. But if I told you it was an element, that would narrow it down. So I start looking. Well, helium is 4, so it can't be helium. Neon is 20. Argon is 39. That's closer, but not right. Krypton is 83. That's not good. Hydrogen is 2. That's not going to work. Nitrogen is now diatomic, so 14 times 2 is 28. That's not going to work. Oxygen, 16 times 2 equals 32. So if I had told you in the problem that this was an element, then that would be identified then as oxygen gas, and that's a common follow-up to this type of question.